Mary, I don't know how to cook small. You keep flowing.
Are you making chili?
I'm making it strong.
Okay.
No, I don't know how to make chili. It's not been something I even ever wanted to make.
It's really yummy, Mom.
I know what my mother used to make.
It smells like chili.
Those are how my mother cooked. We had this big oval
Yeah,
pot.
yeah. You want to take her out?
You know, I have to cut potatoes.
Well, I got to admit these students back into class.
Right now, it's the middle of the day. You take them outside and keep the yard.
All right, I'm going to get up and move for a second. Now I'm wondering if a lot of these students can't get back into class to the end of that meeting.
I can zipper them up.
What?
I think I lost a lot of students when I stopped that meeting.
I think it's because you said take break, and I think everybody walked away, and then you ended it.
Let's see if they come back. Yeah, I hope that's just it. I don't think that it's the time length. I think there's something different about YouTube, and I'm still trying to figure it out. That they're all of a sudden it's not accepting any of the recordings. I got some suggestions about how to fix it, and I will try to get it done soon. I can't say that I'll get it done in the next 2 days, but I will work on it. Yeah, Miranda, I think you're right. Okay. So let's start into bone. So this is where we've talked a lot so far. We've talked about the construction of organisms. We've talked about different ways that different modes by which organisms are what's the word for it, created. What we went through chapter 1, the beginning of anatomy and physiology. We spent some time looking at the chemistry behind physiology and anatomy. Now, oh wait, and then we went through cells. Well, now let's talk about why that all matters when it comes to anatomy and physiology. That stuff is important because you have to understand that is the basis for everything else. So congratulate yourself that you've survived this long in the class and that your brain is about ready to explode, but you're still here and you're still present. And let's start talking about why all of that stuff is so important. So bone tissue. The skeletal system consists of bones, cartilage, and ligaments. Remember, these are your connective tissues, tightly joined together. The cartilage is the forerunner of most bones in the embryo skeleton and bone development in childhood. It also covers the joint surfaces in mature skeletons. Ligaments hold bones to bones at together joints. Tendons hold bones to muscle. So ligaments are part of the skeletal system. And remember, these are made of dense, regular connective tissue, skeletal system. made of dense, regular, let's go back, made of dense, regular connective tissue. And connect bones to bones. Tendons are not part of the skeletal system. Made of dense, regular tissue. I'm going to copy and paste this really quick if I can. We'll find out if this works. Tendons are also made of dense, regular connective tissue, but they contain bones to muscles. And muscles to muscles sometimes. So skeletal system includes ligaments, cartilage, and bone. And ligaments are part of that, even though they're also related to tendons. But ligaments connect bone to bone. That's why they're considered part of the skeletal system. Which of the following could be found on or within a bone, such as the humerus?
The osseous tissue.
What about the others? So if it's part, cartilage would be cover the joint surfaces, so cover the bones. We also find fat in the bones. And we're going to learn that the reason bone breaks hurt so badly is because they're highly innervated. So it's kind of a trick question, Erin, but all of them are part of bone. So the skeleton is a composition of multiple tissues. Here's neurons. Here's yellow bone marrow, which is predominantly adipose tissue. Red blood cells, osseous tissue, some dense regular connective tissue, some red bone marrow, both cases here. Also, bones continually remodel themselves and interact physiologically with all other organ systems. So you think, most often people think the bones are fairly stagnant. They don't do a whole lot except maybe hold you up. We're going to learn here that they have a lot of different functions and that they're involved in a lot of different physiological processes. Therefore, each bone can be considered one organ, with each bone being composed of different tissues working together. Some of the major functions of the skeleton is that they support the body, teeth, viscera, and organs. Work to support and protect soft tissues. They include, for example, the brain, the spinal cord, the heart, the lungs, the pelvic viscera and bone marrow. The skeleton functions in movement, including those involving of the limbs, breathing, and other movements where muscles are acting on bones, with the bones serving as levers. Also, the bones are critical in balancing electrolytes through their abilities to store calcium and phosphate and then release these minerals into the tissue fluids. In addition to being involved in balancing the electrolytes, the skeleton also functions in acid-base balance. Remember, this is your pH. Through buffering the blood against excessive pH changes, by absorbing or releasing alkaline phosphatate and carbonate salts. So both calcium and phosphate can be involved also in the acid-base balance. Because parts of the calcium salts and part of the phosphate salts can be weak acids or weak bases. And remember, that's how a buffer is made. A buffer is a combination of a weak acid and a weak base. The skeleton is also involved in blood formation because this is where red bone marrow is found, which is the origin of blood production and immune cell production. Kind of saw this word in the last chapter. Hematopoietic is a tissue in which new blood cells are formed. As my mom would tell you, also, hema always means blood. Hema always means blood. Poetic, poetic means progenitor or producing cells. Cells that are going to produce something else, or let's just put it here, progenitor cells. We can also, in some cases, we call these a type of stem cell. But they're limited in what they can differentiate into. So hematopoietic are is the tissue from which red blood cells, white blood cells, and platelets are all going to be produced. Which of the following functions of the skeletal system would be considered a metabolic function?
Mineral storage.
How did you know that right off the top of your head, Miranda?
Because this is regulating how much the minerals with the calcium and the phosphate, how much is in your body at all times.
Good job. You're the first person to get that right in the classes I teach. Good job. So she's right. It's because of the calcium and the phosphate storage and release. And that those are involved in metabolic reactions like pH and so forth, and maintaining the structures of proteins. Remember, minerals are often crucial for that. So there's 4 different types of bones. We have long bones that have a greater length and width and consist of a shaft with a variable number of ends, such as a long bone example would be the humerus of the arm. Short bones are somewhat cube-shaped and nearly equal in length, such as your carpal bones or your tarsal bones in your ankle. Flat bones are generally thin and avoid a considerable amount of protection, or afford a considerable amount of protection, such as the bones of your cranium or the bones or your sternum. Irregular bones are bones that have a complex shape, such as your vertebrae, that can't be grouped into either of the other last 3 categories. This next little part, we're going to spend a lot of time talking about bone anatomy. We'll also cover this a little, we'll briefly cover it in lab also. But, starting with that, beginning here. Bones are covered with thin plates of periosteum. Peri means surrounding or covering. If you think about periphery on the outside, let's say, or surrounding or periphery. Osteum always means bone. If you think osseous tissue, osteum always means bone. Endo, do you remember what endo means? You've seen this word a couple times. What does it mean?
Outside.
Say it one more time, Jessica.
Outside.
It's exactly the opposite.
Inside.
Inside. So endo means inside. So periosteum is a connective tissue dense, irregular connective tissue. That covers the outside of a bone. Endosteum covers the inside of the bone. So thin plates of periosteum are going to cover the outer surface of the bone. And the outer surface of the bone is compact cortical bone. Endosteum covers the spongy or cancellous bone that's inside. It looks spongy. So it's called spongy or cancellous bone. Where the bone marrow is housed in between what are called trabeculae. Trabeculae means little bars. It looks like little bars. Very hard bars, but bars all the same. So surrounding the internal surface of the bone is the endosteum, which, since the inside of the bone is spongy bone, endosteum is going to cover the surfaces of the spongy bone. Red bone marrow is located within the trabecular cavities, the holes. So compact or cortical bone, it lines the outside of a bone. Periosteum covers the cortical bone. And the cortical bone is going to enclose the marrow or medullary cavity inside the bone. We call it the marrow cavity because it's where the red bone marrow is found, or yellow bone marrow is found, depending on the location of the bone and how old you are. What was I going to say? Medullary. We either call it the bone marrow cavity or the medullary cavity, because medullary or medulla I'm going to let a student in who's in my next hour, but he's right here, so we'll let him in. Medullary is the inner bone cavity, or actually medullary means inner cavity. Inner cavity. My mom's listening in on our conversation. She's a great teaching assistant. So cortical bone encloses the marrow medullary cavity that contains the bone marrow. The spongy or cancellous bone is in the central space at the ends of the long bone. and it's inside the shaft or the diaphysis of the bone. Whole area is the shaft. So we find cancellous bone on the ends of the bone in a long bone and lining the diaphysis or the medullary cavity. The ends of the bone are called the epiphyses. Epiphyses. The distal end is a distal epiphysis. The proximal end is the other epiphysis, the one closer to the middle of the body. Remember, what does epi mean? Talked about the epidermis in lab. What does epi mean?
Inside.
You're close. Endo means inside. What does epi mean?
Oh, outside.
Outside or on top. So like your epidermis is your top layer of your skin. Your epiphysis is on the ends of the bone. The metaphysis is where the diaphysis or the inner shaft meets the epiphysis. A lot of epiphyses here. So epiphysis, diaphysis, epiphysis. With the metaphysis, meaning where the diaphysis is going to meet up with an epiphysis. In long bones, the epiphyseal growth plate is made of hyaline cartilage, where the growth of long bones occurs. When your long bones stop growing, your epiphyseal plate, which is about where the metaphysis is, remember? I did say that. So your epiphyseal plates are found at the metaphyses that are where the diaphysis and the epiphysis are joining. When the growth plate stops forming new bone, this is because the epiphyseal plates is where long bone elongation is going to occur. When that stops occurring, an epiphyseal line will form here, being an indication that the epiphyseal plate or growth plate has fused. Articular cartilage is a layer of hyaline cartilage covering the regions of the epiphyses where the bone will articulate with other bones. Any questions so far? So from this slide, I remember that the epiphyses are on the ends of the bone. The diaphysis is in the center of the bone. The metaphysis is going to connect the diaphysis up with the epiphysis. And the metaphysis is the location of the growth plates or the epiphyseal plates that are made of hyaline cartilage. And when growth when you stop growing, when the long bones stop growing, this growth plate fuses and becomes the epiphyseal line. And we'll talk about how that happens when we meet again. So where do you find hyaline cartilage in the bones?
And the articular cartilage.
In the articular cartilage, where else do you find it, Miranda?
I'm looking through my notes.
Just look specifically at this slide.
Growth plates.
You find it there, but where else do you find? Oh, you're right. Okay, yes, you're right. You mentioned the one before. So at the articular cartilage, meaning where the bones are going to articulate or move with other bones. And then at the epiphyseal plates. So the medullary cavity is the space within the diaphysis that in adults, and once you're in the approximately at the age of about 10 or so, it usually becomes filled with yellow bone marrow. We'll talk about the red bone marrow and the yellow bone marrow later. The medullary cavity is a space within the diaphysis that contains the yellow marrow in adults. The yellow marrow is fatty tissue that can act as a reserve for a fuel supply. The endosteum is a layer of reticular connective tissue that lines the inner bone marrow cavity. You remember I said that it was dense, irregular connective tissue before? I was wrong. It's reticular connective tissue. Do you remember where you find reticular connective tissue? Where do you find reticular connective tissue? This was from lab. Someone Google it on their phone. Where do you find reticular connective tissue?
In the layer of the dermis.
Nope.
Okay.
You find areolar and adipose tissue there. And sometimes, yeah, areolar and adipose.
Bone marrow and liver?
Bone marrow and liver and the spleen. You're right, Jesse. So why do you find it? If it's involved in the liver, it's involved in the spleen. These are immune filtering organs, the spleen and the liver. Why do you find it in the bone marrow?
Bone marrow has all of the dense nutrients, right?
Well, it has some nutrients, but what is ultimately what's going to form from the bone marrow?
Is it because the cells are rapidly being like reproduced and created and destroyed?
Sort of. It's because this is where all new blood cells are going to be coming from. One of those blood cells is the white blood cell. I don't know if we've talked about this or not, but why do we have white blood cells? What do?
They fight off infection.
Yeah, they're involved in the immune system. So reticular connective tissue, coming down here again, reticular connective tissue is a tissue found in the immune system. The red bone marrow is a part of the immune system. So that's why the endosteum that lines this cavity where the red bone marrow is lined with reticular connective tissue. I hope that helps clarify that. That's why the periosteum is dense, irregular connective tissue, and the endosteum is a reticular connective tissue. So the endosteum, this reticular connective tissue, has cells within it that dissolve osseous tissue and others that deposit it. This is where we get calcium and phosphate being stored and released. Also. The nutrient foramina, foramen or foramina, which we'll spend a lot of time talking about this, or we'll talk about it again in lab on Thursday. But the foramina foramen or foramina means whole. Singular foramen, plural foramina. So these are small holes. Nutrient foramen are small holes where blood vessels enter the bone, blood vessels and nerves. The periosteum, tough, fibrous, collagenous layer, dense, irregular connective tissue with an inner osteogenic. If you remember, we talked about genesis. Genic meaning bone forming. What does osteo mean?
Bone.
Bone. So this is cells that are going to form bone. So periosteum, tough, fibrous, collagenous layer with an osteogenic layer of bone forming cells. Some collagen fibers are continuous with tendons. Remember, tendons connect bones to muscles. Some collagen fibers of the periosteum are perforating fibers, meaning called Sharpie's fibers, that are going to penetrate the bony matrix. So that's how the periosteum sticks to the bone, is through these perforating Sharpie's fibers. General features of flat bones is that we have a sandwich-like construction. We have two layers of compact cortical bone that enclose a middle layer of spongy or cancellous bone, with both surfaces being covered with periosteum. Remember, the compact bone is always covered with the periosteum. The inner spongy cancellous layer is covered with the endosteum. Within the flat bone, the spongy cancellous bone is called the diploie, which functions to absorb shock and house marrow spaces that are lined with the endosteum, which we see in all cancellous spongy bone lining. Any questions? bones are made mostly of osseous tissue. Remember, osteum, osseous tissue means bone. The osseous tissue is a connective tissue, a flexible connective tissue called osteoid that is hardened by mineralization. And mineralization occurs by the depositing of calcium phosphate and other minerals in that tissue. So bone has a soft part to it. Bear with me. Bone has a soft part to it, the osteoid, and it has a hard part to it, the calcium phosphate and other minerals. The osseous tissue is therefore this extracellular matrix that has a bunch of widely separated cells in it. The matrix components, so outside of the cells, the matrix component is 15% water, 30% collagen, and 55% mineral salts. So the majority of the osteoid, remember the osteoid is a soft matrix connective tissue, is collagen. The crystallized inorganic salts will become further calcified with calcium phosphate salt, which we call hydroxyapatite. So the calcification of the bone is when osteoblasts, actually, let's learn some more words really quick. Let me finish this and then I'll introduce some more vocabulary. Calcification is the laying down of this hydroxyapatite within this framework of collagen fibers. So where we're adding minerals to harden this softer osteoid connective tissue. So osteoid is predominantly collagen with some other fibroblasts and other connective, other things involved. So predominantly collagen with some fibroblasts in it, which are a type of cell. In it. If you remember fibroblasts, we saw them when we were talking about the different tissues. They're a progenitor cell for many connective tissue cell types. They're the major cell involved in connective tissue. Remember, osteo means bone. So blast in front of a word is a cell that's involved in building or secreting. Cells involved in building or secreting. Do me a favor, if you're not gonna write, if you don't write down any other words that I type up in this whiteboard, write these down. Because we're gonna see them over and over and over again. So osteoblast, bones and blast means cells involved in building or secreting. Blast means cells involved in breaking down. And one more, site is a cell that is kind of in senescence. So it's kind of just in a state of not really dormancy. It can come out of dormancy really fast, but it's not, it's just maintaining. So let's say cells that are just, they're just be there, that are dormant. So osteoblasts are bone cells involved in the building of matrix and the calcification. Osteoclasts are cells that are involved in the breaking down of bone. Osteocytes are cells that are dormant and are just kind of maintaining the structure. They're there, they're present just to maintain. The principal component of bone that contributes to its hardness is what?
Would that be the hydroxypeptide?
You're right, Isabel. It's the hydroxyapatite. That's the calcium phosphate salts. So bone consists of cells, fiber, and ground substance. There's 4 basic principal types of bone cells. There's osteogenic, remember those are the progenitor cells. Osteo meaning bone, so bone progenitor cells. Osteoblasts, osteocytes, and osteoclasts. Osteocytes maintain the bone tissue. Osteoclasts form the bony matrix. Osteogenic are a stem cell that will be able to form new osteoblasts. And osteoclasts are cells that break things down, break down bone. So osteogenic cells are continually multiplying stem cells that arise from embryonic mesenchyme. Remember, mesenchyme is the embryonic connective stem tissue, or the embryonic connective tissue. Osteogenic cells are present in the endosteum, meaning on the inner lining of the bone marrow cavity, and on the inner layer of the periosteum. Osteoblasts are bone-forming cells that undergo osteogenesis. What does genesis mean?
To create, to produce.
Good job, Miranda. To create or produce. So osteogenesis meaning to produce bone. So osteoblasts produce the organic material of bone, which is called the osteoid, and promote the mineralization or the hardening of that bone. They don't divide, but originate from osteogenic cells. Bone stress and fractures will stimulate mitosis. Remember, mitosis is cell division of osteogenic cells to result in increased numbers of osteoblasts. I'm going to stop just for 1 second. Let me finish talking about bone cells here for a minute, and then I want to show you something. So osteocytes are former osteoblasts that are trapped in lacunae. Lacunae are cavities. Lacunae are cavities. Okay, cavities. So osteocytes are former osteoblasts that are trapped in lacunae within the matrix they deposited. The best way for me to describe an osteocyte for you is if you imagine yourself, you're painting a house, you're painting a room, and you're not being careful about what area of that room you've covered in wet paint. And when you're almost finished painting that room, you realize that you've trapped yourself in a corner by wet paint. So osteoblasts will secrete matrix, and promote the mineralization of that matrix. And then they realize that they've trapped themselves in that matrix. The corner where they've trapped themselves is the lacunae, the cavity. So they've trapped themselves in a cavity by producing all this matrix. And once they're trapped in that cavity, they're called osteocytes because they can't keep secreting matrix right there. There's no room to move. There's no room to keep secreting it, so they're stuck. Osteocytes have cytoplasmic processes or caniculi that connect them to other osteocytes that allow them to pass along nutrients and chemical signals and eliminate metabolic waste. So these are little tunnels that connect caniculi are little tunnels that connect one osteocyte to another, allowing them to obtain nutrients because remember, they're kind of stuck in this cavity. So this is how they obtain nutrients and eliminate waste. Osteocytes contribute to the homeostatic, remember homeostasis, homeostatic balance of bone density and blood concentrations of calcium and phosphate. They resorb bone matrix while others deposit it. Actually, let's not say this. I'm realizing there's a mistake here. Put functions over here. So bone cells in general contribute to homeostatic maintenance. Osteoclasts absorb bony matrix while osteoblasts deposit it. Actually, yeah, that's correct. Strain sensors
I'm
are
sorry, Professor, could you repeat that one more time?
osteoblasts deposit matrix while osteoclasts resorb it. Strain sensors are found where increased pressure on the bones results in a flow of extracellular fluid in the lacunae and caniculi. Stimulating osteocytes, remember these are the maintenance cells, to secrete signals that regulate bone remodeling, causing changes in bone shape and density. Osteocytes can, remember they're dormant, but they can come out of dormancy and become osteoblasts again. These are osteocytes or osteoblasts that have kind of trapped themselves. With certain signals, osteocytes can become osteoblasts again. So osteoclasts are formed, remember osteogenic cells produce osteoblasts, which will then paint themselves into a corner or secrete a bunch of matrix and become osteocytes. Osteoclasts, in contrast, form from the fusion of bone marrow stem cells, so hematopoietic cells. Osteoclasts are involved in bone breaking down or bone dissolving cells that promote osteolysis. Remember, lysis means to break down. Osteo means bone. Osteoclasts form from the same bone marrow stem cells, the hematopoietic stem cells, as blood cells do. And multiple hematopoietic cells will fuse to form an osteoclast. Osteoclasts have a side facing the bone surface that is ruffled to increase the efficiency of bone reabsorption. And osteoclasts reside in resorption bays that they carve into the bone. Now, because my mother is dying for me to get rid of exhibit lessons. I'm trying to think what you call them. I'm going to show you something really quick. In 1 second here. Let me see how little. Well, he's got to stick around for another. This is only the first class. So I found something really fun online, and my mother's about ready to lose it with me. I'm lucky I have such an understanding roommate. But if you take a chicken bone and stick it in vinegar for a long period of time, you can do it with any long bone, probably any bone. I stuck these chicken bones in vinegar. How typically are bones fairly hard?
Yes.
Okay, so this bone I've stuck in vinegar, and I'm gonna lower the screen just a little bit so you can see him fairly well. And he's actually been in vinegar for quite a while. Vinegar, because of the pH, it's a pretty good preservative. So these haven't gone bad because they've been in vinegar for easily about a month now, maybe a month and a half, maybe 2 months, somewhere there. But if you look at it, do you see that I'm able to bend it? Can you see it? Can you see it?
Yeah, we can see it.
The vinegar has dissolved away what causes bones to be hard. What causes bones to be hard?
Calcium and phosphorus.
Yep, the calcium and phosphate. So the vinegar dissolved away the calcium and phosphate. And the result is that I'm just left with osteoid, collagen and fibroblasts and some other connective glues. If you take this another long bone and stick it in, stick it and heat it for a very long period of time. This will be my next experiment. My mother's going to be really excited. You heat up a bone and heat it up for a long period of time at a high temperature. You can dissolve away all the osteoid and then you're left with just the calcium. Keep in mind right now, and remember this for next time, that the collagen is very much necessary for the flexibility of bone. The rigidness of bone comes from the hydroxyapatite. There's a balance. You have to have both. And I will see you guys on Thursday.
Have a good day.
You too.
Bye, guys.
Thank you, Professor.
You're welcome.
See you,
Then,
Professor.
thank you.
Welcome.
Oh, no. Oh, could we,
Not completely, like 20 minutes. Yogesh and Michaela, are you still here?
Yes.
Can I help you with something?
And I was saying, my phone kept losing service today, so I was like in and out.
It's all right. I understand. And I
I
will
was like,
I will try to get the recordings posted as soon as I can, as soon as I figure out what the problem is. It takes me a little while to do it. Every week I spend about 2 hours just posting recordings.
oh wow.
So the fact that they haven't been working means that I need to solve the problem. So be patient with me and I will get them posted.
Oh no, that's yeah, no. I was just trying to let you know because I know my thing kept going like in and out. So I was like,
Yeah.
oh gosh. Okay.
Don't worry about it. I understand. Okay,
All right. Well, you have a blessed day.
you too.
Bye.
Yogesh, are you here?
Yeah, I am. I'm sorry. I just like doing some other things.
Okay. Have a good day, okay?
You too. You too. Thank you.